Okay, grade A, series A homeworks. So you're going for the big questions near the end of the paper, but even though it's grade A lot of them are fairly straightforward. Method might look different, but if you can understand the method through your homeworks, you're more than halfway there. First question is a stratified sampling one. We love that because they're always fairly straightforward. You're going to sample 60 students out of a school. In total, there's 820 students in the whole school. So, because it's stratified, which means it's proportional to however many of each group there are, then I don't just get 60 students and split them into 5 groups. How many year 8 should be in a group? The fraction of year 8s in the whole school is 200 out of 820. So the same fraction of your sample of 60 should be year 8s. So we'll get 60 times by 200 divided by 820. I get 14.63. I can't question 14.63 students, so I'm going to have to use the usual rules around it, and I'm going to have 15 year 8 students in my sample of 60. Second question, it says solve, and the clue is, it says give your solutions correct to 3 significant figures. That means we're going to be using our calculator and we're going to be using the quadratic formula and not trying to factorise it. Quadratic formula, there it is. Minus b plus or minus square root b squared minus 4ac all over 2a. A is the coefficient of x squared, which is 3. B is coefficient of x, which is minus 4 because you have to include the minus. And C, similarly, isn't just 2, it's minus 2. It's useful to write them down. Fill in each part of the formula. So the 2a is now 2 3s is 6. Minus b is minus 4, so that's plus 4. B squared is 16. Be careful because it's not minus 16. Minus times a minus is a plus. Minus 4 times 3 times minus 2. It's very important you double check that, because this is not 16 take away 24. It's 16 add 24 because of the 2 minuses. Sometimes if you miss that, you'll end up trying to take the square root of a negative number, which you can't do now, but you can do with us next year when we do complex numbers. The plus and minus is where the question split up into 2, because you're actually finding the roots of a quadratic, and so you will have 2. So we take the positive, which is 4 plus the square root of 40 divided by 6, it's on a calculator, 1.72. Make sure you press equals before you press the divide. Take the negative 1, 4 minus the square root of 40 divided by 6 minus 0.397. And double check to make sure I'm going to get all the marks. It says 3 significant figures. I've done the answer to 3 significant figures. I've got to draw a histogram. I need to work out how high each of the bars should be. Now, in histograms, you plot frequency density as the height, not frequency, because if the bars are different widths, it would look disproportionate if you just used the height. So the frequency is 15, which means the area of the bar has to be 15. Well, if it's 5 wide, 5 times 3 is 15. I could have done 15 divided by 5 is 3. The second bar has got to represent 25. Well, it's 5 wide because it goes from 65 to 70. And 25 divided by 5 means it's got to be 5 high. And similarly, I'll do 24 divided by 20. Because this is a much wider bar, it's not going to be as high. So these 4 numbers are your values for frequency density, and that's what will go on the vertical axis. Okay, part 2. We've got a vectors question. I want you to think about vectors as little roads all originating from out. And you've got to get from there to point N. Now it says point N is such that dn, distance from D, compared to the distance from C, is in the ratio of 1 to 2. So if that was 1, this part is 2. So that means it's 2/3 of the way up the line. So to get from O to N, I'm going to go along vector B, which ends up with B. Then I'm going to go from B to C, and then I'm going to go from C to N. Now B to C is the same direction and distance as the vector A, so that's why I wrote A there. And Cn is actually 2/3 the same direction and distance as that vector. If I was going all the way to D, I'd just do another A, but I'm actually only doing 2/3 of it. So if I tidy this up, I've got 1B and 1 2/3 A, which I might write as 5/3A. Question 5 is, because it says solve to 2 decimal places and now I'm using our super formula, I write down what the values of A, B and C are. A is 3, B is 5, C is 1. There's no negatives there. I'm going to fill them in and make sure I've got my minus B. B squared is definitely 25, minus 4 times 3 times 1. In this case, you are actually taking away 12. 25 take away 12 is 13. And then, because it's a plus or minus, I'll take the plus first, and then I'll take the minus. And if you work those out on the calculator, you will end up with the two answers. Give it to 2 decimal places, so that one's okay. And I need to round that to be minus 0.23 to make sure I'm complying with what I've been asked to do. Question 6, circle theorem. I'm told DAB is 47. Well, if I look at this shape here, it's actually a nice kite. Now AB are tangents, O is the centre, so that's a radius. Tangent and radius meet at 90 degrees. So I've now got a four-sided shape with 47, 90 and 90. Well, that means that the angle here at O will have to add up with the 47 to make 180, so I've got 360 inside the four-sided shape. Well, 180, take away 43 is 133. So this angle there is 133 degrees. And I've got to find BCD. So go from B to C to D, so we need to find this angle. Well, actually, angles at the centre are twice the angle at the circumference. So if this is 133, the angle at C has got to be half of it. So half of 133 is 66.5 degrees. So I've used one circle theorem for radius and tangent. I've used good old-fashioned knowledge of quadrilaterals there for the 360. And then I've used the second circle theorem. Angle at the centre is twice the angle at the circumference. You might have to give you reasons, so you've got to make sure you include all of those explanations. Okay, higher on in your paper, you're not looking at volumes and surface areas of different shapes. So if I ask you a volume of a sphere, there's a formula, 4/3 pi r cubed. It's usually written at the front of your paper. Radius is 14, I'll just substitute my 14 in. Do it carefully on the calculator, straightforward. If you don't know that formula, it's fairly difficult. But if you realise it's actually written at the front of your paper, there's some easy grade A marks. Variation. T varies directly with r squared. That means T is something times r squared. So when r gets bigger, T gets bigger. You've got to work out what this something, this K, this constant is. Well, we're told that 648 is T when r equals 9. So 648 is something times 81. So if we divide 648 by 81, we'll end up with 8. And that means K is 8. In other words, the formula, which will be right from here, is T equals 8R squared. So if I'm then told how much R is, I can just do 8 times 12 squared, 8 times 144, job done. Equally, they could have told us what T was, and we could have divided by 8, found out what R squared was, and took the square root. The first part is always subbing in the two values you're told to work out K. If it's directly proportional, it's multiplied. If it's indirectly, it'll be divided. Okay, last question. Area of a triangle. I can't use half the base times the height because I don't know the vertical height, but I'm lucky because if I ever have two sides of a triangle and the angle in between, I can use this lovely little formula. Half AB sine C, where A and B are the two sides. Doesn't matter what order you've got them in. What matters is that you have the angle in between them, and that's C. So if all three letters are different, you'll have two angles and two sides and an included angle. A half times 37 times 29 times sine of 45. On a calculator, make sure it's on degrees. That's the area. Works perfectly. If you wanted to do it slightly longer, you could consider that half of your triangle to be a right angle triangle and work out the vertical height, but actually you'd be using sine anyway. You'd be timesing it by 37 and you'd be halving it because it's the area of a triangle. So that's actually where the formula comes from. It's much easier if you know that it's written in the front and you know how to use it. Look for the two sides and the included angle. Well done.